Hello friends, today we are going to start chapter number 2 of Matrix Algebra. So that chapter number 2 is linear equation in linear algebra 1. Okay, all students are familiar with what is meant by linear equation. All study in 11 and 12 standard what is meant by linear equation. So let us start chapter number 2, that is linear equation. Chapter number 2, linear equations in linear algebra 1. Linear equation in linear algebra first. Okay, this is your chapter number 2. So let us start. What is meant by linear equation? Okay, let us write down definition. What is meant by linear equation? It is very easy concept. All students are familiar with what is meant by equation and what is meant by linear. Linear means degree of that equation is 1. Okay, so let us start definition. Linear equation in variables. A linear equation in variables x1, x2, up to xn. Okay, a linear equation in variables x1, x2, up to xn is an equation that can be written in the form of a1 x1, a2 x2 up to an xn equal to b. Okay, what is my linear equation? A linear equation in variables x1, x2 up to xn is an equation that can be written in the form of a1 x1 plus a2 x2 up to an xn equal to b, where a1, a2, up to an and b, all these are your real numbers, where a1, a2 up to an, all these are your coefficients. Okay, and all these coefficients, and your right hand side is your b. What is your right hand side? Right hand side is your small b, which is also all these numbers are your real number, and x1, x2, up to xn, all these are your variables or unknowns. Variable also called as unknowns. All are unknowns. Another word is variables. Okay, this is your linear equation. Okay, so let us start example. What do you mean by linear equation? That is an equation in the variables x1, x2. First example, x1 plus 2x2 equal to 2. Okay, x1 plus 2x2 equal to 2. This is your linear equation in variables x1 and x2, and where the coefficient of x1 and x2 are 1 and 2, and your right hand side is also 2. So all these are your real number. This is your first example. Second example, 3x plus 2y equal to -1. This is also linear equation. In how many variables? Here variable is 2, x and y. In first example, how many variables? 2 variables, x1 and x2. Let us take the third example. x1 plus 2x2 equal to 5, and 2x1 minus 3x2. Okay, again minus 4x3 equal to 2. Okay, this is your again in third example. There are two linear equations. In first equation, two variables x1 and x2, and in third equation there are three variables, that is x1, x2 and x3. There are three variables, and in that equation there are two equations. In third example there are two linear equations, right? So take one more example, that is x1 plus 2x2 plus 3x3, x1 plus 2x2 plus 3x3 plus 4x4 equal to 1. And second example, x1 minus 2x2 plus 4x3 plus 5x4 equal to 2. Okay? In that fourth example number 4, there are two linear equations. In the first linear equation there are four variables, x1, x2, x3 and x4. All these are variables. And in also second linear equation there is also four variables. Okay? So all these such type of example are your linear equation. In that such linear equation, it is the collection of all. So it is the collection of all linear equation. In the first example there is only one linear equation. In second example there is only one linear equation. In the third example there are two linear equations. In the fourth linear example there are also two linear equations. So let us turn to the next definition. What is meant by system of linear equations? Okay. Let us write down next definition. System of linear equation. What is meant by system of linear equation? System of linear equation. What is meant by system of linear equation? Now system of linear equation. So from this all the above example, it is a collection of. So write down from the following example. From the following examples. From the following example. It is collection of. From the following example, it is system of linear equation. It is a collection of one or more. It is collection of one or more linear equation. It is collection of one or more linear equation. It is collection of one or more linear equations. Linear equations in same unknowns or same variables. Same unknowns or another name is variables. Okay? It is collection of one. It is collection of one or more linear equation in same unknowns. Mean that in that two equations. So first equation there is variable x1 and x2. And in second equation there is variable also x1, x2, x3. That is same variables. So such collection is called as system of linear equation. Such collection is called as system of linear equations. Okay, so this such type of linear equation is called as system of linear equation. What is my system of linear equation? A system of linear equation, it is the collection of all linear equations in which one or more linear equation. It is collection of all linear equation in which one or more linear equation and same unknowns. In that linear equation there is same unknowns. Such collection is called as system of linear equation. Okay, so let us write down next definition. What do you mean by solution of system? Our next definition, that is solution set of system. Okay, and our next definition, that is definition of solution set of a system. What is mean by solution set of a system? It is so easy definition. Solution set, another definition. A solution set of a system. A solution set of a system is a vector. A solution set of a system is a vector S1, S2, Sn. Okay. A solution set of a system, or we can talk the word here, that is solution. What do you mean by solution of a system? A solution of a system, a solution, that is solution of a system. A solution of a system is a vector, that is S1, S2, S3 up to Sn. That makes each equation. Two equations. That makes each equation is two statements. That makes each equation two statements. Okay. A solution of system is a vector, that is S1, S2 up to Sn is a vector. That means each equation of the system is a two statement when values of S1, S2, Sn. Okay. When values of S1, S2, Sn are substituting or another word is, or putting the values for x1, x2, xn respectively. Okay. This is called as solution of a system. What do you mean by solution of a system? A solution of a system is a vector S1, S2 up to Sn. That makes each equation of the system is a two statement. That means each values of S1, S2, Sn, okay, is then replaced for x1, x2 up to xn, and this vector is called as solution of a system. Okay. So let us write down next definition. And all such collection of the system is called as solution set of a linear system. Okay. So the next definition. What do you mean by solution set of a linear system? Okay. So the next definition. Solution set of a linear system. What do you mean by solution set of linear system? It is so simple, easy. So meaning in that word, that is, it is a set of all possible solutions. Okay. So definition. The set of all possible solutions. The set of all possible solutions. The set of all possible solutions is called as solution set. Okay. The set of all possible solutions. So that all solutions which are comes is called as solution set. Is called as solution set of a linear system. The set of all possible solutions. Right? The set of all possible solutions. The set of all possible solutions is called as solution set of a linear system. Okay. What is my solution set? The set of all possible solutions is called as solution set of a linear system. So let us write on the next definition. What do you mean by equivalent linear system? Okay. And the next definition. Equivalent linear system. What do you mean by equivalent linear system? It is so simple definition. And what definition? Two linear systems are equivalents. Okay? Two linear systems are equivalents if two linear systems are equivalent if they have the same solution set. They have the same solution set. If the two systems are said to be equivalent if they have the same solution set, okay, then the system is said to be equivalent linear system. Okay. So let us now look at the example. Let us now look at the first example. If a linear system, consider a system of linear equation. Consider a system of linear equations. Consider a system of linear equations in two variables. Consider a system of linear equations in two variables x1 and x2 such that. So what is your first linear equation? That is x1 minus 2x2 equal to minus 1, and second example is minus x1 plus 3x2 equal to 3. Okay. So it is the following system. Okay. In the following system there are two linear equations and these two equations are linear. Linear means degree of each equation 1, and in which variable? Two variables x1 and x2. Okay. This is your system of linear equation. Now if we have to solve for the system for x1 and x2, before that we have to represent this system in graphically or geometrically. Okay. So we have to represent this system geometrically. That means a linear equation in the 2D plane, that is xy plane, it is a line. Okay. What I am saying, this is your x-axis, this is your y-axis. A linear equation in xy plane, this is your linear equation. Okay. Where x-axis become x1 and your y-axis become x2. And this linear equation in xy plane, that is 2D dimension, become a line. Right. So now if we have to represent this two equations in x and y plane, so your x-axis become your x1 and this is your y-axis become x2. Okay. We have to represent this two linear equations on a graph or on a 2D plane. So how can this point? This is your x1 point, this is your x2 point, right? And this is your point x1 comma x2. Okay. We have to represent this line. Okay. So if for first line, if x1 become 0, if x1 is 0, put the value of x1 become 0. Then minus 2x2 equal to minus 1. This minus minus cancel. So x2 become, that is 1 by 2, right? If the first equation x1 minus 2x2 become minus 1, and the minus x over 3 to become 2. Okay, so this is your 0. Okay, suppose this point is your 1, this point is 2, this point is 3. Okay, suppose this point is minus 1, this point is minus 2, this point is minus 3, this point is minus 1, this is minus 2. Same, this is 1, this is your 2, this is your x1 axis and x2 axis. Okay, if we have to put the value of x1 become 0, x1 is 0, then we get minus 2x2 equal to minus 1, minus minus cancel, then value of x2 become 1 upon 2, right? Value of x2 become 1 by 2. So what is called it? 0 comma 1 by 2, right? Same, if value of x2 is 0, value of x2 is 0, then value of x1 become minus 1. So value of x1 become minus 1. What is called it? Minus 1 comma 0. Okay, we have to represent the first linear equation. What is find? 0 comma 1 by 1. So this is your x coordinate is 0, right? And what your y x2 coordinate become 1 by 2. 1 by 2 is this point, right? So this is your point, right? 0 comma 1 by 2. Next point is minus 1 comma 0. So on your x axis, this is your minus 1. x1 is minus 1, right? And y coordinate is 0. Okay, we have to join this line. Okay, this is your first line, called as first line. This is your line L1. Okay, similarly we have to draw for the we can draw for second line. This is your x1, this is your x2, right? And this is your x1 comma x2, right? So if we have to take the value of x1 become 0, if x1 become 0, then what is this value? 3x2 equal to 3, then 3 cancel. So x2 equal to 1. So x2 equal to 1. What is point? 0 comma 1. Second, take value of x2 become 0. Take value of x2 become 0. So we get minus x1 equal to 3. Minus x1 equal to 3. Therefore x1 equal to minus 3. So x1 is minus 3. What is this point? Minus 3 comma 0. So we have to plot this 2 point 0 comma 1. This is point 0. Here is point is 1. This is your 0 comma 1, right? And second point is minus 3 comma 0. This is your minus 3 comma 0. Okay. Now we have to this is your line, right? This is your line yellow. Okay. Now we have to join these 2 points. Okay. This is your line L2 line. Okay. So we have to join these 2 points, and this point is, suppose this point is your A point. Okay. So from this plotting this 2 linear equation, we have to plot line L1 and L2. After this plotting, we get one intersection point, and this intersection point is your solution of that linear system. Okay. So we get one intersection point. So we get one intersection point of that 2 lines. Such point is solution. Such point is solution of the solution of linear system. Okay, that such intersection point is your solution of linear system. Okay, and so how many points we get? We get only 1 point. That is, so we get unique solution, right? That is, we get unique solution, right? So we get unique solution. Okay.